Good evening, EEL 6535. My name is Brittany English and I will be presenting on RFID this evening. There are several different ranges that RFID works in. Each of the different ranges has a specific application that's commonly used for it due to the ranges or regulations or other aspects about that particular range that exists. The different ranges are from 120 to 150K, which is low frequency, 13.56 megahertz high frequency, a 433 megahertz, which is ultra high frequency, and another ultra high frequency band, which in Europe is the 868 to 870 megahertz, and in North America is 902 to 928 megahertz. And there's two microwave bands. The smaller one is 2.5 gig to 5.8 gig, and the larger one is 3.1 gig to 10 gig. The formulas that I used for my calculations are that the bit rate is calculated by multiplying the symbol rate times the number of bits per symbol. The information rate is calculated by multiplying the bit rate times the code rate, which is given. And the bandwidth efficiency is calculated by dividing the information rate by the signal's frequency. So the different coding schemes that I'm going to use are PSK, ASK, and FSK. Those ones are fairly commonly used in the RFID. Generally, simpler schemes are used here because RFID is a very low cost type of signal. So generally they use very simple coding schemes, and they use these three most commonly from what I've found. The code rates that I've picked are 1/2, 2/3, 3/4, and 5/6. A bunch of different code rates can be used, but I just picked these to show the different values. And for the M values, I picked 2, 4, and 8. Once again, because these are the smaller values, and RFID tends to use the smallest, simplest values most commonly due to its low cost. First, we're going to look at the low frequency, which is the 120 to 150 kilohertz. This frequency band is unregulated and publicly accessible. It only has a range of 10 centimeters though, so that's why it's unregulated, and they don't really care who uses it because you're not likely to interfere with others. The most common uses for this range are for animal identifications, like how you can get a tag injected into your pet, so if it gets lost and someone finds the pet, they can scan the pet and find your information, even if the pet were to lose their collar. Or for data, factory data collection, really you can put these tags on any sort of equipment that you have, or any sort of little parts and pieces that you're worried about going missing, and you're able to scan them and quickly read all the information pertaining to that part. This standard is outlined in ISO 18000-2, and it most commonly uses two different types of symbol rates. One is 1,200 bits per second, or 9,600 bits per second. And there's the reference that I looked up this information at, and the bandwidth efficiency ranges from 0.4% to 20%. And here are the calculations for ASK. with the symbol rate of 9,600. And as you can see, bits per symbol for an alphabet size of 2 is 1, bits per symbol for alphabet size is 4 is 2, and bits per symbol is 3 when the alphabet size is 8. And ASK, PSK, and FSK are all the same, so that doesn't matter. It's more the alphabet size that changes things. I tried each of the code rates out on each alphabet size, and these are all the 9,600, as I said before. So our bit rate is calculated in this column here. Our information rate is calculated here, and our frequency ranges, since we have a range, are shown here. And so we see the bandwidth, the high and the low, using each frequency. So these are all of our bandwidth efficiencies, and all these were calculated using the formulas in the previous slides. And as you can see, our range on this slide is 0.032 up into the 0.2. And on our next slide here, I calculate all of that again using this 1,200 symbol rate. And here on this slide, we have a range of 0.004 to 0.025. So our overall range is from 0.004 to 0.2, and so it really depends on what code rates you use, what alphabet size you use, what symbol rate you use. But in this range, those rates are what would be most commonly seen. Next, we're going to talk about the high frequency range, which is that 13.56 megahertz. This is an ISM band, and it has the ISM band worldwide regulations, but it's publicly accessible. The regulations are fairly minimal, but there's a few, and the range is 1 meter. And this is most likely used in things like smart cards, ID cards, different things like that. If you need to scan to get in a door, anything like that is most commonly used this frequency. And it's outlined in the standard ISO 18000-3. And its symbol rate ranges anywhere from 9,600 bits per second to 115,200 bits per second. And here's a reference that talks about that, a couple references actually that talk about that. And using the calculations that we previously talked about, I found that the bandwidth efficiency that's most commonly found here ranges somewhere between 0.0003 and 0.0212. And here are our calculations. Once again, this table is laid out as it was previously. And you see there's one less column because here we don't have a range of frequencies. We only have one frequency. So we have one less column, or two less columns actually, because there's only one column for frequency and only one column for bandwidth. And as you can see here, the ranges for the 9,600 are shown here. And here is the range for the